So in this particular question, we need to find the limiting value of the given function when x approaches negative infinity. So on substituting for the value of x, we have the indeterminate form of infinity minus infinity. So that means we need to convert the given function, which is f of x, to a rational form of g of x over h of x. But before that, we are going to do a substitution here that let y is equals to negative x. So that means when the limiting value of x is negative infinity, or you can say when x approaches negative infinity, that implies y approaches positive infinity. Because we have x as negative infinity, so y will be equals to negative of negative infinity. So that simply means that y goes to positive infinity. Then we can make the transition here. So we have limit y going to positive infinity, and we have square root of negative y squared. So since y is negative x, or we can simply say that x is equals to negative y. So we have y squared, so negative x will be positive y plus 1 minus negative y. So this is the function whose limiting value we need to determine. That means we need to multiply it by its conjugate, which will be simply the square root of y squared plus y plus 1 plus y, and we have to divide it by this particular conjugate as well. So we'll have square root of y squared plus y plus 1 plus y. So we have limit y going to infinity. So we have square root of y squared plus y plus 1 whole squared minus y squared, because we have a minus b times a plus b in the numerator, which transforms to a squared minus b squared, which will be divided by the square root of y squared plus y plus 1 plus y. That should give us limit x going to since we're working in y, so we have y going to infinity. So we have y squared plus y plus 1 minus y squared divided by y plus square root of y squared plus y plus 1. So the y squared and the negative y squared will cancel out, leaving us with y plus 1 in the numerator. So we have limit y going to infinity y plus 1 divided by y plus the square root of y squared plus y plus 1. Now the highest power of y in both the numerator and the denominator is 1. So we are going to divide both numerator and the denominator by y. So we have limit y going to infinity. So the first term of the numerator will become 1. And the second term will be 1 over y. For the denominator, we have y over 1y, which is going to be 1, plus the square root of y squared plus y plus 1 over y. So the y will enter inside the square root and become y squared. And that will leave us with 1 plus 1 over y plus 1 over y squared. Now substituting the value of infinity, which is the value of y. So we have 1 in the numerator divided by 1 plus square root of 1, which is simply 1. So the limiting value of the given function is equals to half. So we need to find the limiting value of the given function when x approaches negative infinity. First, we are going to assume that y is equals to negative x such that when x approaches negative infinity, then y approaches positive infinity. This will give us limit y going to positive infinity. So we have x, which is negative y, which we have y squared. So minus 8 times negative y will make it a positive 8y minus y. So this is the transformation that we have made. Now we are going to multiply it by its conjugate, which is the square root of y squared plus 8y plus y. Then we have to divide by the same conjugate. So we also have y squared plus 8y plus y in the denominator. That gives us limit y going to infinity. So we have y squared plus 8y minus y squared. So here we have used the identity that a minus b times a plus b is equals to a squared minus b squared, divided by square root of y squared plus 8y plus y. Now the y square and y square gets cancelled, leaving us with 8y in the numerator. So we're going to divide both numerator and the denominator by y. So that leaves us with limit y going to infinity. So 8y divided by y will be simply 8 divided by the square root of, so we have y squared here. So we have y squared plus 8y, the square root of it, divided by y. So the y will move inside the square root, so that will become y squared, so that the first terms becomes 1 plus 8 times y over y squared, so that gives us 8 over y plus y over y is simply going to be 1. Now when we substitute the value of y with infinity, so that will give us 8 over 1 plus 8 over infinity is 0 plus 1, which is equals to 8 over 2. So the limiting value of the given function when x approaches negative infinity is going to be equals to 4. So we have to find the limiting value of the given function. Clearly this function is of the form positive infinity minus infinity, which is an indeterminate form. So here we make the transformation that let y be equals to negative x, such that when x approaches negative infinity, this implies that y approaches positive infinity. So we have limit y going to positive infinity, square root of 4 times negative y squared, so that will be 4y squared, minus 7 times negative y, so that will make it positive 7y, minus 2 times of y. So now we're going to multiply it by its conjugate, so that will be simply 4y squared plus 7y plus 2y, and we have to divide it by the conjugate as well. So we have square root of 4y squared plus 7y plus 2y. So we have limit y going to infinity. So the numerator has the form a minus b multiplied to a plus b, which will be equals to a squared minus b squared. So we have square root of 4y squared plus 7y squared, so that will give us 4y squared plus 7y minus 2y squared, which will be negative 4y squared, divided by twice y plus the square root of 4y squared plus 7y. So now we're going to divide the numerator and the denominator by the highest power of y, which is 1. So that means we have to divide it by y. So we have limit y going to infinity. So 7y divided by y is going to give us 7, divided by twice y divided by y is going to be 2, plus the square root of 4 plus 7 over y. Now we're going to substitute the value of y, so that will leave us with 7 over 2 plus the square root of 4. So square root of 4 is 2, so we have 7 over 4. So this is going to be the limiting value of the given function when x approaches negative infinity.